So what we're going to talk about in this video is the product rule for taking a derivative. So as you see in the first line, the derivative of an f of x times a g of x is the derivative of f times g plus f times the derivative of g. So basically you differentiate one and multiply by the other original and add. So as we're going to see here in this example especially, we're going to first look at products that don't necessarily need products. So we're going to manipulate it algebraically as well, just to make sure that our results match up. So with this one here, what I'm going to do is I'm going to write the derivative of each piece. So that means this is 6x, and this is 3x squared minus 2. So that means that the derivative of the product is the derivative of the first times the second plus the first times the derivative of the second. And then what we'll do, we use some algebra to simplify the expression. So that means this is 6x to the fourth minus 12x squared. And then on the right here, we're going to FOIL. So 3x squared times 3x squared is 9x to the fourth minus 6x squared plus 12x squared minus 8. So combining like terms and whatnot, it looks like I have a minus 12x squared and a plus 12x squared. That worked out nice. That might have been a fluke. So it looks like we have 15x to the fourth minus 6x squared minus 8. Now in another color, what I'm going to do, I'm going to take the original expression and I'm going to FOIL it first, because like I said before, we really didn't need the product rule in order to find the derivative. We could have multiplied it out first. So multiplying term by term, so FOIL again. So 3x squared times x cubed is 3x to the fifth. The outers give you negative 6x to the third. The inners give you 4x to the third. And the last times the last is minus 8x. So that's going to be 3x to the fifth minus 2x to the third plus 8x. And then when you take the derivative of that, that's going to give you 15x to the fourth minus 6x squared plus 8. Oh, I'm sorry, minus 8. I don't know how my plus became a minus there, but that was an obvious typo there. And you notice we get the same exact thing. So whether you multiply it out first and then take the derivative or use the product rule, you should get the same result. And the thing is, we're going to get into examples later where we absolutely need the product rule. We're not going to have a choice because we don't have that ability to multiply out. So let's look at another one. Now here, the interesting thing about this is it's not written as a product right now, but I'm going to go ahead and write this as 4x plus 3 times 4x plus 3. So that means using the product rule, so taking the derivative of each part. So that means they're both 4 because they're both the same. So that means we have dy dx is equal to the derivative of the first times the second plus the first times the derivative of the second. Seems a bit repetitive. And we have 16x plus 12 plus 16x plus 12. And that gives us 32x plus 24. And that's the final simplified answer. Now, again, if I manipulate it algebraically, and you realize we were one step away from that anyway, if I FOIL that, I get 16x squared plus 24x plus 9, and then the derivative is 32x plus 24. So there again, we got the same result doing it two different ways. So for now, like I said, the whole point is to practice the product rule, but just realize that you can always, for now, you can multiply it out and check your answer that way. So thanks for watching, and we'll talk about quotient rule and chain rule coming up soon. So stay tuned for more videos. And again, thanks for watching.